Welcome to another episode of Job Tales. There are many jobs that fall under the category of software engineer. Today I'm talking with Julian Kent. He's a software engineer specialized in robotics. He studied at the University of Cape Town. Today he is a core technology team lead at PXL Vision in Zurich. Julian, what made you choose this path?
I guess always since a child, I've been somebody who's been sort of, in the engineering direction. I've been, playing with Lego or whatever with that. But then also at around 12, 13, I got really into radio control airplanes. And my initial thought going into university was that I was going to do aeronautical engineering. And so I joined the mechanical engineering stream at University of Cape Town. And yeah, was doing really well there, really enjoying it. So another thing I got into late in high school was software for robotics. There was a game called Robocode where you program the artificial intelligence for a robot. It's everything from the super basics to you can start getting to really advanced statistical systems for this. And yeah, that was a hobby. And I never thought it would turn into a job. And I was pretty set on aeronautical engineering as a real profession. But then 2 years into university, we had to make a decision whether we stay pure mechanical or whether we switch to electromechanical, which then gives us basically the first 2 years of electrical engineering, plus on top of you already have your 2 years of mechanical engineering. And I actually ended up taking that decision because I'd really liked some of the electrical stuff that I'd been exposed to until that point. And that ended up with me doing a project in my final year of undergrad in the robotics lab. And yeah, ended up much more on the software side, actually, even though my degree was much more in mechanical engineering.
So you said that before that you knew that it was not going to become your profession, in robotics. Why that?
I really enjoyed I guess for me with the radio control airplanes, it was the design side of it much more than the flying side of it. And for me, it was always about build another one, change something, try a new shape of wing or a new type of material, or putting the propellers in a different orientation or something like this for the airplane. And this was something that is very much sort of core aeronautical engineering. And I thought, that's something I'd love to do. And I seemed pretty good at it, even without formal training. So I thought, play to your strengths and try to go that way. But the robocode was something that came later. I think I didn't have the tool set for it when I first got into it. And as I went into university, I started getting a bunch of more the calculus and trig and stats that I needed to really be able to expand my skill set on that side. And as I got better there, it it let me know sort of what I could be doing there. And I think it inspired me a bit more. There was more there for me to explore.
And when you say robotics, interestingly, you said before on our call that it is a sort of like a nerdy romanticism. Can you actually tell me from what you learned, what is robotics and what actually people think or expect robotics to be?
When people talk about robotics, like the first thing that comes into mind is, like Mars rovers and, like little dancing robots in Japanese competitions or however it is. But actually, so much of robotics is completely integrated into our everyday lives. We're just not aware of it. Anytime you have mechanical systems with electrical systems hooked together, you essentially end up with robotics systems. And that can be anything from like dishwashers and washing machines to the stuff like the Mars rover. So just to give an example, like everyone who has a car, you think of all the design stuff that went into the car. So things like on a car, there's the windscreen wipers, there's the how all the buttons that interact with the electrical and the mechanical side work. That's a huge part of robotics as well. But I think one of the biggest things of robotics is actually industrial robotics. So things like assembly lines that are automated. When you build a car, it's much more complicated, the design of the assembly line, than the actual design of the car. Otherwise, you just build one car, and that's not very useful. You want to build thousands of the cars, right? So the design of the whole factory that builds the cars is where the robotics engineering comes in, because you have these electrical and pneumatic systems that are having to do precise motions and putting pieces together, picking things up, moving them around. I don't know if you've ever seen, for example, the automatic spray painting machines that they use in car assembly
Yeah.
lines.
Yes.
Like, this is a classic example of a crazy, complicated robotic system with multiple joints in the arms and exact motions that have to be planned for the spray painting. And like, I think a lot of robotics is actually completely invisible to our everyday lives, but really, really critical.
That's an interesting point. I mean, it's a very good point because I also had that the romanticism about robotics and what that could envision. So when you then finished university, were you a software engineer at the end, or were you a mechanical engineer?
So I finished my degree, and actually one of the guys who'd been the external examiner on my undergrad project had afterwards, after I had graduated, asked me if I was interested in joining his company. And I did a quick internship there in between my undergrad and master's. And then when I finished my master's, I'd enjoyed my time, so I went back and asked if he wanted to take me on full time, and he did. So that ended up being almost entirely software engineering. There was a little bit of electrical engineering when we were having to design a second generation product, but it was mostly software. I think that set me very strongly down the path of software engineering. I think I was also very lucky in that the company that I chose as my first company to try to get a job at had really high standards of work. So they had a lot of very good engineering practices that they insisted on for everybody. And to me, that's given me a huge boost in my career in terms of making sure that the work I do is of high quality and that my expectations are high, both for myself and for my teammates.
Awesome. And how long was that? How long ago was that?
So I have now a bit over 8 years of industry experience, and I was at the first company for 2 years.
Okay. And that was in
That
South
was in
Africa?
Cape Town.
Okay.
Yeah.
Okay. And then from the company to Zurich, what was the jump?
From there, I moved to Lausanne, and I was working at a computer vision company there, Pix4D. They make photogrammetry software, so they take the images from any source, but they focus primarily on drones, and they use those to reconstruct accurate 3D models of the ground that are then used for things like architecture or civil planning or forestry, agriculture, these types of things. So I joined there as part of the core calibration team. So this is the team that figures out the exact parameters of the camera that took the pictures so that you can essentially turn what is something that's probably actually designed just to make things that look nice into something that's more like a precision scientific instrument by calibrating it. And once you have that calibration, then you can figure out exactly by tracing all the correspondences from one picture to the next. Like, say you have a bunch of pictures of a field, you can say, the corner of the field is over here in this picture, and it's over here in this picture, and it's over here in this picture. So once you have all of the pictures and you know what angle they were taken at and what exact you say, like the zoom level of the lens and how fisheye the lens is and these kinds of things, you can triangulate these points in all the images, and from that you can rebuild the entire 3D model. And so that was really cool. Really got me thinking really hard. And again, I think the good practices that I had from the first company really paid off there. I was able to contribute at a very high level, and after about a year and a half, the company was opening a second office in Berlin, and I volunteered to be one of the people to found the office.
Okay. So you went to Berlin.
Yeah, so then I went to Berlin, and we started on a brand new product that was building or doing basically the same thing, but for agriculture. And agriculture has very different requirements to things like architecture because they don't care about this sort of centimeter level accuracy of the outputs. Instead, they care about very accurate color reproduction. They call it radiometry. That instead of geometry, it's the radiometry of the problem because they need to know exactly which sections of the plants are healthy, which areas might have diseases, which areas might have different compositions of soil, which could mean that they need to add either fertilizer or lime or clay or something to various areas of the fields. So they care about different types of things. And another thing is that with agriculture, unlike with the normal architecture stuff, often they have very, very big areas that need to be surveyed. Particularly, it's less so in Europe, but more so in the US. They have these giant, giant farms that just stretch, horizon to horizon. And so there, it's more important that you process the results quickly, even these very, very big data sets. And also, if you can get the results quickly on site, you can then use them on site to quickly take some like leaf clippings or soil samples that can let you further enhance the model that you're building of how the ground is in different areas, what types of treatments you're going to need for the ground.
I see. So yeah, so it's a lot of mapping, and then it's
Exactly.
a little bit like when you do weather forecasts for for insurance companies so that they can predict and
Exactly.
okay.
That's actually one of the primary use cases of the agriculture was for insurance companies because the farmers insure their crops at the beginning of the season in case there's freak storms or diseases that come through so that the insurance company will then cover them and they don't go bankrupt due to one bad year. So if they can get a more accurate prediction of what the yield of their crops will be, the earlier and the more accurate they can get that prediction, the less premium the insurance company will have to charge them because they have less uncertainty. So this was one of the big things, one of the big applications for this. So anyway, I was there. I got that product working, and at some point ran out of stuff there, or a bit saw other things that I wanted to work on and got curious, and ended up coming to Zurich, where I was working at a drone company. And the goal there was to work on obstacle avoidance systems for drones. So I guess this is, and I still think this is one of probably the primary reasons that we don't have more drones flying around in a call it a unobtrusive manner closer to people and things like this is the safety and reliability around obstacles and things like wires from telephone poles, small tree branches. Somebody lets go a balloon and there's the string dangling below it. All of these kinds of things can cause problems, and teaching drones to stay away from them is actually surprisingly difficult.
And we're talking about non-passenger drones. So imagine when we're going to
Exactly.
have to get to the Beatles, the vertical takeoff and landing
Yeah,
machine.
yeah, yeah, for sure. And for these kinds of things, I think it's not going to be as free for all as the way it is with the toy drones that you buy in the supermarket or the electronics store or whoever it is, just for safety reasons.
Yeah. So this is your current company where you're working?
I was there for 3 years, and yeah, eventually we hit a limit with what the existing sensor technology could do. Building brand new sensors that could do what we actually needed, I think, was beyond the scope of what the company was willing to invest in, considering that the obstacle avoidance was not their primary market that they were trying to solve. So after that, I was working on the general autopilot stuff at the company for a while, then shifted to the current company I'm at. And this is now I'm back in image processing, out of the drone space completely. I'm working on a company, or with a company that does ID verification, so ID document verification specifically. So this is for things like if you sign up for a car sharing service or you want to register online for a cell phone contract, they will need your ID document and they need to check either for legal reasons or for their own internal accounting reasons because they don't want to send out expensive things or give access to vehicles because that they don't have proof of, that you're qualified to use it. So they need to make sure that the person who's applying is A, the person who they actually say they are, and B, that they have the qualifications that they say they do. So maybe that means they have a permanent residency to qualify for the cell phone contract. Or maybe it means that they have a qualification for a driver's license and they have 2 years of experience, which is of driving, which is what is maybe required for a car sharing service. So what the company does then is they take pictures of the ID document through an app and also a selfie video of the person, and then we make sure that the ID document, we extract all the information off of it and verify that it's a real ID document. And then we also match the face in the selfie video to the face on the document and make sure that everything is legit.
I see, and all this is done digitally, and it's also
Yes.
backed up. You run a database to check the missing information.
So most things you can get directly off of the document.
Okay.
For us, we just do the document extraction. Some customers then further integrate that directly with maybe a database from the authorities to make sure that, particularly for much more sensitive things like notarizing documents, things like this, they might need to check that the person is on the list of notaries, these types of things.
Nice. So you've basically changed I believe 4 or 5 jobs in 8 years, which is awesome. I mean, I thought I changed jobs too quickly, but actually, I'm happy to see that the trend seems to be, back in the days of maybe my parents, you would hear that a lot, that, you need to stay in a job for as long as you can because you need stability on this. But the job market is changing drastically, and now having actually a CV with jobs that change every 2 years or a year and a half is actually not that rare anymore.
So it's interesting, actually, more of my job changes have been internal inside of the company than, or I guess it's been balanced pretty much. Yeah, I guess 4 companies in 8 years. But yeah, it is so 2 years, 3 years, 3 years, and now currently I'm 1 year at the current job.
You think that in order to proceed with your career and to grow in your role, you would need to have to spend at least a certain amount of years at a company before changing?
I think there's a certain amount of time. I don't know if it's per company, and I don't know if it's a time thing, but I think you need to see projects through to completion from the beginning where the idea comes to the end where it's sort of where the project is no longer receiving attention and is now sort of in just maintenance mode.
Yeah. Okay.
And that can take different amounts of time depending on the company, depending on the product. I think it's important to have seen this. Because it helps you get that full feedback cycle to know when you're doing something early, what problems are going to end up happening later on in the cycle. I think particularly with startups, pace is much faster than it is at bigger companies. Projects live and die much more quickly. The company might realize, oh, hang on, we actually need this and we need it yesterday. And so you end up on sort of a lightning project cycle where in under a year, you've gone from the initial idea of a project to having released it, and then it's basically on maintenance mode and just in the background providing value, and everybody gets shifted onto another project. Whereas in a big, much larger company, I think this is usually a 2, 3, 4 year cycle. I've twice done projects from the beginning right through to the end maintenance mode, and it's really valuable having that insight. And it's also frustrating then later on when you're working with people who haven't been through that, and when you're trying to explain why something's important, but they haven't seen it and they don't know what problems are going to come up later. I think both are valuable, Having this slower pace means that you can do a much deeper level inside of the project. You can go a lot deeper. You can spend a lot more time polishing each tiny little piece to get it perfect. But actually, it's sort of the 80-20 rule, right? You can get 80% of the work done in 20% of the time, but then that last 20% takes 80% of the time. So depending on the problem you're trying to solve and how well it needs to be solved, you can get an amazing amount of work done in a small amount of time. You just have to be able to live with the fact that some of the problem won't be fully solved.
Your field is going to be changing a lot in the future. What kind of trends are you already identifying as you work in the industry? You know, software, you know, robotics in a sense. What do you think will be maybe the future jobs that will be needed and requested?
So the thing with software, it's this one type of engineering that has basically zero production costs. It's only design costs, right? It's like if it were software is if you wanted to compare it to like buildings, software is just the architect's plans. It's just that. And after that, you don't really have to pay for the bricks and the cement and the land value and all. Or if you do, that part of the cost is pretty negligible compared to the upfront design costs. So the thing with software, and I guess people saying, software is going to eat the world, to some degree, it's true, I think, for anything that everyone can use the same solution for. When it gets to more customized stuff, I think a lot more people are going to get into the software field doing more specialized things, because what we have right now, it works well as long as millions of people are using it. And I think this sort of, we're going to end up in much more, people want some software for their school, and their school has specific requirements, and they don't want to use a generic off-the-shelf solution. Or, their school, I'm making an example, but I think pretty much any industry is going to realize that the generic off-the-shelf solution actually leaves a lot of space for improvement that they could actually realize themselves if they had the expertise in-house to do it. So I really think that in terms of careers, if you're good at something else and you learn software, then this cross-functional strength is going to be, it's an absolute killer. It's like a superpower, right? If you have something in your industry where people spend hours copying stuff from one spreadsheet to another or something like this, software can do that in a few seconds. The problem is that you need to have somebody who understands the problem well enough to be able to actually apply the software solution. So I really think that in terms of software skills, if you just have software skills, you need to be really good. If you have skills somewhere else as well, then if you add some software to the mix, and you don't need to be crazy good at it, you can already make huge improvements in your industry. Another thing I think with data, and you were talking about the increased digitalization of everything, I think particularly personally identifiable data, and I'm talking now in my industry of things like ID documents, but also things like photos of people, maybe records of payment transactions, records of internet browsing history, all of these kinds of things are going to start to be less and less seen as an asset and more as a liability. Just because we're now seeing a lot of a shift in mentality of things like GDPR that are making big fines for anybody who loses this data or misuses this data or doesn't delete it when the user asks or doesn't give the user a way to ask to delete it. These things are now massively finable. And I think to some degree, this is the right direction. We need to have a little bit of a reining in of people having control over their own lives again. I think the pendulum swung too far in one way, now it's swinging back, and we'll see where it settles in the long run. But I think there was this very big hype of big data over the last 10 years, and I think this is going to maybe pendulum back a little bit, where people start seeing the liabilities of holding this data and how difficult it is to stop hackers from getting it, to stop employees from leaking it, or to use it even as a consistent benchmark or a reference when customers are asking for it to be deleted or legally they're not allowed to use it unless customers gave their consent for it. So I think data is going to change in its value a lot, maybe even go into something that has negative value.
Looking back at your 8 years of working in the industry, is there any lesson you've learned that others can benefit from that you would like to share?
To make this accessible to a general audience, I would say the biggest thing for software is don't be afraid to throw it away and start again while the problem's still fresh in your mind. So often with software, you write the first, I would call it the prototype of the code to the solution you're making. And while writing the prototype, you learn more about the problem than you knew when you first architected the initial solution. And by writing it, you understand the problem so much better that if you throw it away and start again, you'll end up with a much better solution the next time around. And often, while the initial cost might be higher, the total effort that you'll expend if you want to support this software over a longer period of time will make it very, very worth it, because the simpler solution in the long run will be much, much easier to maintain or adapt to different types of situations. So yeah, so not being scared to throw it away and start again while the problem is fresh in your mind is absolutely super important. I guess the corollary to this is if you were not the one who wrote the initial solution and you don't have the entire problem in your mind, then be very scared about throwing it away and starting again.
Okay.
Because you're probably going to make a whole bunch of mistakes in your iteration that the people the first time around didn't make, even if you fixed a bunch of things that they didn't solve last time.
Solve. Okay.
Yeah.
I mean, I could go on listening to you for a long time. But coming to a conclusion, I would like to ask you, what, according to you, are the one top hard skill and the one top soft skill that a software engineer should have?
So the hard skills, I think, are being able to understand things as systems, right? So understanding how different things fit together, like cause and effect of different things, and having an intuition for how this causes that, how that fits into that, how data flows from one place to another, what you need to do to change data from one type to another, how to most efficiently represent something. These are the types of, I think, hard skills that you will generally, I think you might even know you have them before you become a software engineer. In terms of soft skills, I would say if you're somebody who likes, I guess, the general problem solving, and if you're in math in school, you get these word problems, like something is described as, the train takes this long to get from A to B, and how long does it take for, at the same time a bird is flying in the other direction. And if you're somebody who can translate these types of descriptions into the actual math problem, I don't know, maybe this falls under the hard skills as well, but this is actually 99% of what software engineering is about. Customers don't know what their solution needs to actually be. They just know what problem they have. But they try to explain things in the way of the solution to the problem they have. So you have to go back and turn and understand the problem they have from the solution they gave, and then figure out the best way to actually solve it given the software that you know. So if you just try to directly implement the solution that customers will typically request, it won't actually solve the problem because the customers have the problem because they don't understand that solution.
Right.
Right. So you're not going to solve the problem with the same thinking that made it in the first place.
Yeah.
I don't know. Maybe this is a bit more of a hard skill.
Maybe it's an intertwined hard
Yeah.
and
Yeah.
soft skill, because
Yeah.
not everybody has that skill. Yeah, for sure.
Yeah. In terms of soft skills, I would say being able to collaborate with people. There's some software that you can do on your own, but in general, it's in teams. And if you can express your thoughts to people, explain your thinking, and then understand other people's point of view and understand why something might be better, even if it's not your idea, or why someone else's idea has a problem, and you're able to give constructive criticism without criticizing the person, but just the idea, I think this is a huge part of software engineering, being able to give feedback in a team all the time about what type of issues you have and how to make things better.
Yeah, that's an important point because, in my imagination of a software engineer, it will be someone who is in front of the computer alone and doing the job just on his own or her own. But it seems that what you're saying that the bulk of the projects are really like a collaborative effort between colleagues and between software engineers. Is that right?
Absolutely. Everywhere I've worked up to this point, any code you write gets reviewed by other people before it gets integrated into the main code base. So this means that you'll spend a fair amount of your time having to give feedback to other people, technical feedback, but this, of course, is communication. And at the same time, you'll be receiving technical feedback, but it's communication. And the better you are at communicating technical ideas in a way that other people understand them and other people want to like them, the more success you'll have as a software engineer.
And that was Julian Kent's job tale in software and robotics engineering. Do you have a job to suggest? Is there one you would like to know about? Then reach out to me at jobtalespodcast@gmail.com.